Hi everyone, welcome to my Test Your Mettle. I'm going to jump right in with the poem I wrote inspired by the first law of thermodynamics. I live here. Everyone I love lives here. It is a heart-shaped box collecting my joy. It is a cauldron of hot magma and sorrows. It is all the things that have been and all the things that will be. The universe. Science seeks to unlock its secrets, the pursuit of truth, and a darling droplet of water careening around the planet practices the truth. That droplet, it has been here before, and it will return, because the universe does not waste. Oh no, she conserves. And so this presentation will celebrate the economy and elegance that is conservation, a big idea put in play because of the first law of thermodynamics. Wernher von Braun affirms this big idea of conservation with his quote, "Science has found that nothing can disappear without a trace. Nature does not know extinction, it only knows transformation." Von Braun's quote asserts that disappearance, extinction, is not an option. More specifically, the first law of thermodynamics states that energy and matter cannot be created or destroyed under ordinary chemical means. The implication is that energy is finite. We are not losing any or making more. Rather, the energy shapeshifts. It transforms from one form to another. The challenge becomes how to teach this big idea and make it relatable and engaging. I chose to deep dive into thermodynamics with weather. Weather affects our lives every day, for better or for worse. More importantly, our planet is in a climate crisis. Weather is changing dramatically because of it. To shake loose ideas, a brain map was created. This is a visual interpretation of concept ideation, and it helps because you're forced to spend time with the ideas rattling around in your head and to see how those ideas connect and influence each other. For example, looking at the central image of the brain map, you will see that it is a recreation of a smartphone weather app. From this are four branches, four reaches from the main idea. The first one is energy. The energy in the system being the Earth, moves water around the planet. The more energy there is, the more movement there is, and a consequence is bigger, more dangerous storms. The second branch addresses energy transformation. Case in point, when the rain droplets are captured in the cloud, they possess potential energy. When they begin to fall, that potential energy is transformed into kinetic energy. The third branch is heat. Heat is a type of work, and temperature describes heat. Furthermore, temperature is a measure of the average kinetic energy of the particles in the system. The last branch expands on work. Work is the ability to move against a resisting force. Examples of work being applied in a weather system is the formation of clouds or when hot and cold fronts unite, which creates a weather event. Now it's time to get to the guts, learning activities. How can these concepts be investigated in a meaningful way? The learning activities I created are designed to lead the learner through the natural and unnatural weather phenomena through the lens of energy. The first learning activity is an investigation of a natural weather event, rain shadows. It is built as an inquiry activity in which the learners will observe the windward and leeward side of Mount Hood. They should notice that the windward side is lush and green, whereas the leeward side is brown and dry. They will compare average annual precipitation of towns adjacent to one another but are separated by the mountain. They will see that the windward side has far more precipitation. Then they will hypothesize why. The next step of the lesson is instructional, in which the rain shadow phenomenon is explained. Here is where the movement of clouds, because of the energy present in the atmosphere, will be discussed. Follow-up will entail a review of the process with an emphasis on how energy and pressure affect water particles. The second learning activity will be on the greenhouse effect. I have found that kids have misconceptions about why climate change is occurring. They often think it is because of a hole in the ozone layer. This activity will serve to clear up misconceptions as well as reinforce the concept of the first law of thermodynamics. I believe that kids of this generation do best with visuals and especially interactives. Therefore, I will employ a PhET simulation in which learners can observe visible light descending upon the Earth from the sun's energy and the resulting infrared re-radiation. They will be able to manipulate the concentration of greenhouse gases, thereby thereby increasing the amount of re-radiation that becomes trapped. A series of guiding questions will prompt them through the simulation. The third learning activity will connect energy and matter transformations with climate change. Students will be given a list of words which include both matter and energy. They will be asked to create a visual product in which a web of arrows connects the words. Red arrows will be used for the energy items, and blue arrows will be used for the matter items. They will work alone first and then be given the opportunity to collaborate. The activity will culminate in a series of questions that address climate change and the profound contribution of the first law of thermodynamics. The visual they create will be their reference, their anchor, to field the questions. And here we land on the most poignant and, as the slide indicates, simplest implication of the first law of thermodynamics. Currently, there is not a backup plan. There is not a planet B. In effect, what we do matters. It has always mattered. It's just now catching up with us. Our actions do not remove matter or energy from the system. They only change the components of our universe. Change is reliable, omnipresent, and inevitable. If that change is for the greater good or otherwise, it is in our hands.